Hey, Abubakar.
Good evening.
Good evening. Good evening. Oh, Doha isn't here, no? Doha.
Sir, yes, sir.
Fine. Yeah, I was saying that in the chat box, I have dropped a PDF. Okay. Let me share it once again, Abubakar. You might not have got it. Copy and paste. Okay. So today you guys are going to give this mock test in the batch. This mock test which I have just shared. See.
Yes, sir.
So I have taken questions from different chapters, like there are questions from crop production, microorganisms, combustion, flame, and combustion is there, combustion and flame, coal and petroleum, force and pressure. All right, conservation of plants and animals. From these chapters, these questions have been taken. You guys have around 45 minutes. Try to answer all these questions during this duration, so that we will have time to discuss it also. Okay. By the way, just let me 1 second. In question number 11, you guys will be doing these two actually. All right, not the first two ones, not the first two ones, but the second two ones. Getting it? What I'm trying to say?
Yes,
No,
sir.
No, not getting it. See, the first option is like LFOISSUELF. That one is not to be done. All right. Neither is B. Neither B. You guys have to do this one. A and B. That one. COBMT. That one. And OTLP. That one. Okay, now Abubakar and Priyanka. All
Yes,
right.
sir.
And there are some subjective questions also. And please turn your camera on during the class, during the test. Okay. All
Sorry,
right.
sir, I joined late.
Okay, no worries. Try to join on time. All right. So all of you turn your cameras on, please. So Doha, we had this chapter that is the structure of atom that was important to be discussed. All right. So let us start the discussion of this chapter. Okay. By the way, thanks for sharing the PDF. I got the PDF you had shared with the team yesterday or 2 days ago, right?
Sir, today.
Yeah. Okay. See, so the chapter name is the structure of atoms. Okay. And the notes which you shared, only those points have been taught in your school, right? Only those topics were discussed, right?
Yes, sir.
Nothing,
Only those.
nothing extra, right?
No, sir. Nothing.
Okay, okay, all right. So let us start the discussion now. See, as you know about the atom, so we know that atom is the smallest structural and fundamental thing of everything, right? Like as you know that everything around us is made up of, like everything around different kind of matters that we see around ourselves right now, whether it be in the solid state, liquid state, right, or whether it be in the gaseous state. Okay, so all of them are made up of atoms. So we say that atoms are the building blocks of matter now, right?
Yes,
Abubakar,
sir.
turn your camera on. Okay. By the way, others don't need to pay attention to this lecture. You guys are required to attend the mock test. Okay, now Priyanka and Abubakar. Yeah, good.
sir,
So
I cannot turn my camera on.
okay,
Sir,
no
sir,
issues.
because I
Just
have
give the
some
test.
background issues.
No issues. Just give the
Sir,
test.
means
Mm-hmm.
my network also gets off, so
Okay.
yeah.
Okay, then I won't force it. Okay, see. So getting back to it, what I was trying to say. So atoms are the building blocks of matter, Doha, right now. It's the smallest unit of matter. Okay, it's the smallest unit of matter. And matter is anything that occupies space and has got some mass, right?
Yes,
Anything
sir.
that we see around us, like for example, this thing in my hand, it occupies some space and it has got some mass, so it is a matter. But what is it really made up of? So we say that it is made up of atoms, right? So atoms makes up everything in the world. Okay. Then what are elements? So elements are pure substances that are made up of only one type of atom now, right? For example, we have elements of iron, copper, helium, lithium, beryllium, and so many things are there, right? So elements are made up of atoms, only one type of atom. It is important to note down that suppose if you have an element, let us say you have got sulfur. So sulfur is an element, okay, and it is made only out of sulfur atoms. No other atoms will be found in it. So hence elements are pure substances. Okay. So they have specific atoms and they are unique atoms. All right now. Like the atom of sulfur and the atom of let's say copper, they are different things. Further, we say that all atoms are neutral, meaning that overall charge on them is zero. Right now, overall charge on them is zero. Why? Because we find that the number of electrons and protons, if the number of electrons and protons are same on an atom, so overall there will be net zero charge on it. Right? The same negative charge and positive charge, so hence it is zero. All right. So as I was saying moments ago, atoms are the smallest unit of matter and it is made up of some subatomic particles. So they are total of 3 subatomic particles which we are going to be learning about. So they are protons, neutrons, and electrons. Right now. So when we looked inside the atom, we found out that there are some subatomic particles also inside the atom, respectively these 3. All right. Okay. In the center of the atom, we have got nucleus. In the center of the atom, we have nucleus. It is where all of the mass of the atom is contained actually. When different experiments were conducted, so we found out that almost all the mass of the atom is actually concentrated in the center. Getting it?
Yes, sir.
Okay. So first of all, let us learn like what is found within the center, that is in the nucleus. So in the nucleus of the atom, we have got protons and we have got neutrons. Okay. Also, different peoples have been associated with the discovery of these different particles. Okay, na? There have been various scientists and each one of them have discovered these particles. If I were to talk about protons, so they are the positively charged particles, right? And it
Yes.
was discovered by Goldstein. Goldstein, he conducted some experiments and he discovered it in the year 1896. So discovered was Goldstein. Okay. So they are positively charged subatomic particles. They can be found in the nucleus and have roughly a weight of 1. 1 atomic unit is the weight. Okay, na? The
Okay.
weight of proton is 1. Getting it?
Yes, sir.
Hmm. Roughly we say that it is 1 AMU. AMU is basically abbreviation for atomic mass unit. What does it stand for? Atomic mass unit. To give you a clear picture about like how small this mass is, so the weight of the proton, it is somewhere around, let me write it over here, 1.67 into 10 raised to the power minus 27 kilogram. Isn't it very small, Madhuha?
Yeah. Yes, sir.
It is quite small. No? Hey, Mustafa, how are you?
Fine, sir.
Okay, I'm going to just drop a PDF for you also. Okay, na? So you will also be giving that mock test. Okay, guys. While you will open the PDF course, in question number 11, you will find actually multiple options. I mistakenly have typed there. Okay. So the first options like A and B, you don't have to attempt. You have to attempt the second ones, A and B, this one. Once you open it, now you will understand what I'm trying to say. Okay. These are jumbled word questions. Okay. So answer all the questions during the class duration. Okay. All right. While you guys will be answering it, make sure you follow the proper pattern. Do not miss writing the introductory line. Do not miss like using the bullet points and draw a table wherever required. Okay. So I was saying that protons are positively charged particles, Doha, and they have roughly a mass of 1. This is almost equal to 1.67 into 10 raised to the power minus 27 kilograms. So it is very insignificant actually. Hope it is clear, right?
Yes, sir.
Okay, next is the neutron. So they are also the subatomic particles, but they don't have any charge. Do you see any charge on them?
No, sir.
No, so they have zero charge on them. Okay. Then they also have a relative weight of same as proton. Proton has one atomic mass unit of weight, and this also has one atomic mass unit weight. Please keep this thing in mind that this term AMU I'm using now, it is basically a unit of mass. All right, it's unit of mass simply.
Yes,
Okay.
sir.
Okay, so those were the two subatomic particles. The third subatomic particle, by the way, about the neutron, I didn't told you, no. See, the neutron, it was discovered by James Chadwick. Okay, who discovered it? James Chadwick discovered it. All right. Okay. Third particle was electron. It's a negatively charged particle and it orbits around the nucleus. As you can see here, it is orbiting around the nucleus. Getting it? So it's the only moving subatomic particle in an atom. It's the
Yes.
only moving subatomic particle. Okay. They are located in these shells. We call them as shell. Either we call them as energy levels or simply we call them as orbits also. All these terms are being used for it. Then they have a weight of zero. Their weight is zero because their weight is almost negligible. Okay, na? It is almost negligible. In order to, let us quickly summarize the things which we have discussed. Protons, they are the positively charged particles located inside the nucleus of an atom. Neutron, they don't have any charge, zero charge on them. Their weight is one. Again, it's located inside the nucleus of an atom. While electrons orbits around the nucleus. Okay, in the shell. Okay, they have a charge of -1 and their weight is zero. That is nothing. Okay. Another topic to be discussed is about electronic configuration. So electronic configuration basically tells you about the distribution of electrons in the different shells. Okay, na? So that is about
Yes.
electronic configuration. So let us learn like how it is distributed. Okay. To discuss further, you should know that there are different cells of an atom and we name them differently. The first shell is known as K shell, right? Okay, that is the K shell.
Yes, sir.
Second is called as
L
L
shell.
shell. Good. That is L shell. Similarly, third one is
M shell.
M shell. And so on. Like this one will be the N shell. Okay. So electronic configuration is what? So it basically tells us how the electrons will be filled in the different shell number. Okay. So electrons occupies specific energy shells, K, L, M, N, like that. Okay. Now, if these shells are complete now, so it makes atoms stable. What does it mean? See, as a as we were discussing, atoms can have multiple cells. Electrons are arranged in a specific way. Now, the first shell here, that is the K shell. 1 second. K shell can hold up to maximum of 2 electrons. Okay. Then L shell can hold a maximum of 8 electrons. M can hold 18 electrons. Okay, now, but it will be stable if in the outermost shell of an atom only 8 electrons are found. Getting it?
Yes, sir.
So shells are being filled here in an order now. K was the first shell, L was the second shell, this was the third shell. So there's a general rule for filling the maximum number of electrons in the different shells. And the rule is 2n square, where n is equal to shell number. Getting it? So
Yes,
hence
sir.
first shell 2 electrons, then 8. The third shell can hold 8 electrons. Okay. 2, 8, like the M shell, it can hold although it can hold 18 electrons, but it will be stable only if it has 8 electrons. So in simple, the conclusion is that if in the outermost shell of an atom now it has 8 electrons, then the atom will be in a stable state actually. Getting it?
Yes, sir.
By the rule, like this rule actually sometimes it's failing actually. This rule 2n square, it's failing. Why so? Because the atom will be in a
Sir,
stable state if in the outermost shell it has an 8 electrons. Yeah, Mustafa.
sir, can you repeat what you have to do in the jumbled word questions?
I was saying that the first two options you don't have to do. Okay. The another two options, that is A and B, that one you have to do.
Okay.
Understood now? That is what we
Yes,
are
sir.
saying. Hmm. Then, first of all, the earlier shells must be filled. Okay, now the previous shell should be filled first, and then only the second shell has to be filled. Like, for example, take the case of neon. Okay, in the periodic table, you will find that neon's atomic number is 10. Right now, the atomic number of neon is 10 when you will read the
Yes.
periodic table. Okay. Also, how is atomic number decided? So atomic number is decided by the number of protons found in it. Okay, now number
Yes,
of
sir.
protons found in it. So in the nucleus of neon, you will have 10 protons, and also if it is in a neutral state, it will have same number of electrons also. Okay, so it will have 10 electrons. Let us look how it is distributed. As per the rule of 2n square, as we know, K can have a maximum of 2 only, L can have a maximum of 8 only, right? Although by 2n square, M can accommodate 18, but it fails actually. Okay, na? So it will have a maximum of 8 actually only. Okay, na? Because it will be in the stable state only if it has a total of 8 electrons. Okay. So we must first of all fulfill the first shell, then only fill the second shell. Getting it now? So the first shell
Yes,
has
sir.
2 electrons and the second shell has got 8 electrons. Okay. It's not like we will fill all the electrons in the first shell only. Okay. Similarly, chlorine. In the nucleus of chlorine, there are total of 17 protons. Hence, its atomic number is also 17. Why? Because the number of protons decides the atomic number. Understood now?
Yes.
Hmm. Also, if it is a neutral state, so it will have the same number of electrons, that will be 17. So hence the electronic configuration will be as follows. So in the first one, 2 electron goes. Second shell, 8 electrons goes. How many is left? 2, 8, and then
So 7.
7. So 7 will go in the outermost shell. Okay. But is this chlorine atom, is this in a stable state?
No, sir.
Because the outermost shell is not fulfilled now,
Yes,
right
sir.
now. So it should have a maximum of 8 electrons, but here it's only 7. So it is needing 1 electron now. It needs 1 electron,
Yes.
right? So what it can do, it can borrow 1 electron from other atoms. Understanding it now?
Yes, sir.
Okay. Then it will be in a stable state. Okay. So what it can do, it can make bonds. It can make bonds with some other atoms. All right. So we'll be learning about that also in a while. We'll be learning about valency in a while. Okay. Another concept to be understood is about atomic mass. Okay. Like moments ago, we did learn about different subatomic particles, right? Now, protons, they have some mass, right? A neutron, they also have some mass, but electrons don't have mass. And overall, there will be some mass of this atom. Now, overall, in totality, there will be some mass of it. How do we find it out? So it's quite interesting that atomic mass is simply found out by adding the total number of protons and the total number of neutrons found in it. Getting it?
Yes.
Okay. Okay. So that basically gives us the atomic number. Okay. Suppose, for example, we take the case of neon, let's say. How many protons are there in it? 10. No?
10.
Neutrons will also be same, that is 10. So the atomic mass of it is going to be how much? 10 plus 10, that is 20. Understood it now?
Yes, sir.
So that is the case. Okay. So there were some rules for accommodating the electrons in different shells, right? Although this rule is 2n square, but it fails for many elements. Okay, no? The maximum number
Yes.
of electrons we have discussed, the maximum number of electrons that can be filled in the outermost shell, okay, is 8. Even if it has a capacity to accommodate more than 8, but it can fill only 8. Okay, that is the
Yes.
thing. Okay. Now we have to discuss about valency. Okay. So valency basically tells us about the sharing capacity. Okay, now valency basically tells us about the sharing capacity of an atom. Getting it? But what does
Yes, sir.
exactly it mean? Hmm? Okay, which subatomic particle an atom can share with another atom?
Electrons.
Electrons only, because they are the only moving particles now. Right. So valency, we define it as that is the sharing, or rather we can say combining capacity, combining capacity of an atom. That is how many electrons it can gain, right? Okay,
Yes,
how many
sir.
electrons, I mean to say, it can gain, or it can lose,
Sir,
or it can share. Yeah, Priyanka?
can you send it again? The mock test?
Yeah, sure, sure. Hmm. I have shared it. It will be, it will go in a while. Okay. So I was saying that valency is the combining capacity of an atom. Okay, Doha. Let us take an
Yes, sir.
example of, one second, what happened to this? Suppose we have taken the example of oxygen, right? What is the atomic number of oxygen? What is its number in the periodic table?
Sir, 12.
No, no, no. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. We have got first hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. So it's 8, no?
Oh, sorry, sir. I got.
No issues. So first of all, oxygen, you must memorize elements till 20 at least. Okay, no?
Yes.
By their atomic number in a proper sequence. So its atomic number is 8. Okay. Earlier I did told you that atomic number is basically decided by the number of protons, right?
Yes, sir.
And if the atom is in a neutral state, suppose if it is a neutral state, so thereby the number of protons and electrons will be same in it,
Yes, sir.
right? Okay. So we only need to know about electron right now. So there are total of 8 electrons. Okay. If you were to look at the structure of it, okay, how will the total 8 electrons distributed? In the K, 2 electrons will go in a K shell. The remaining 6 will go in the L shell, right?
Yes, sir.
Okay. So first shell has got 2. Second shell has got total of 6, like this: 1, 2, 3, 4, 5, 6. Okay. Also, you know that the outermost shell is called as the valence shell, right?
Yes.
Valence shell is nothing but the outermost shell. Okay. Now you should also know about the octet rule. It's basically the same thing, that an atom will be in the stable state if the outermost shell has got a total of 8 electrons. So is the octet rule fulfilled here?
No, sir.
Good. Other than octet rule, there's a duplet rule also. Let me write it here. There's a duplet rule also, which says that if the outermost shell has got 2 electrons, then it will be fulfilled. But it is true only for one atom, and that is hydrogen. Getting it? Helium.
Sir, I
How
don't
for
understand the duplet rule.
I will get there. Once let's discuss this question, then I will go to the duplet rule as well. Okay. So it has got 6 electrons only, right?
Yes, sir.
So is it easier for it to lose all the 6 electrons and fulfill the duplet rule, which says that the outermost shell of some atoms can have 2 electrons? Or is it easier for it to borrow 2 electrons from some from some atom?
So it will be easier to gain to
Right now,
borrow 2 electrons.
exactly. So it will need more, two electrons are needed now, right? So oxygen atom needs 2 electrons in order to fulfill the octet rule, in order to become stable. So it will borrow it from some other atoms and it will make molecules, or it can make compounds. And let's understand about its valency also, like what will be its valency. So valency, as we know that, it's basically the combining capacity of an atom, no? How much it can gain, how much it can lose, or how much it can share. If suppose an atom gains 2 electrons, so it has gained 2 extra charges now, 2 negative charges will be there on it,
Yes, sir.
right? If it loses 2 electrons, so there's a surplus of 2 positive charge on it now.
Yes, sir.
Losing like suppose we have taken example of an atom that has 10 electrons and 10 protons in it. Suppose proton is fixed in the nucleus, proton cannot move anywhere, only electrons can move. Now 2 electrons have been lost, so how many electrons are left? 8 now. Proton will be same as it was before. 10
Yes, sir.
proton means 10 plus charge, 8 electrons means 8 minus charge. So overall there's extra 2 charges on it now, right? So
Yes, sir.
if an atom has lost 2 electrons, so its valency will be plus 2. What will be the valency? Plus 2. Can you tell me about this one? If an atom has gained 2 electrons?
Then there'll be 2 negative charges.
2 negative charges. Very good. Okay. Now, for this one, it is easier to gain. So it will gain 2 electrons. Okay. Now it will gain from someone. Okay. And it will form bond. It will form bonds. So thereby, since it has gained, so thereby the valency will be minus 2. Have you understood this?
Yes, sir.
Okay. Now tell me, now let me tell you about some other atoms also. Right now you have learned about oxygen. I was referring to duplet rule also moments ago. So duplet rule is applicable only for some of the atoms. Okay. So it says that some atoms will attain stability if the valence shell has 2 electrons, 2 electrons in it. And it's applicable only for some. Like for example, hydrogen is there, helium, lithium, and beryllium. Okay, and beryllium. Also, all these atoms have been written in a proper sequence actually. Hydrogen with the atomic number 1, 2, then lithium 3, then 4th is the beryllium. All right, now these are their atomic numbers.
So why only these types? Why only some atoms?
We will understand about it in a while. See, if we try to draw the atomic structure of hydrogen, okay, let us draw the atomic structure of hydrogen. That will be the nucleus, right? Okay, this is the K shell. How many electrons are in hydrogen? Proton is 1, no? You know,
Yes.
proton is 1.
Oh, yes.
Electron will also be 1, no?
Yes,
Where will
sir.
electron go? There's only one shell. K shell is only found in it. So 1 electron will go in the K shell. But is it stable?
No, sir.
It isn't stable now. Good. So how many electrons does it need? 1 electron is
One
needed by it.
electron.
All right. Say that nearby this another atom of hydrogen right now. And this hydrogen atom also needs, and here is for nucleus, by the way, okay, not confuse it with nitrogen. So that also has one electron on its outermost orbit. Okay, how about both of them share it? Both of them share their electrons with each other, no? They come together, they make a bond and share it, and one hydrogen sharing bond with another hydrogen like this. Only one
Yes.
bond will be formed like this. Okay, so they are sharing electrons. How many electrons were shared?
One electron.
One electron.
Two.
So no, only one electron was
Yeah,
shared
yes,
between
only one
these two
electron.
hydrogen atoms. So what will be their valency? Will it be plus, minus, or will it be zero? Like what will be it? Hmm?
It will be
Sir,
minus.
Yeah, Mustafa, what you're saying?
sir, after you do the mock test, do you have to share it somewhere, or
Hmm.
do you have to say it?
You will be share it. You will be sharing it. Okay.
Okay.
Hmm.
So it
So
will be
each
minus.
one second. So each hydrogen atom shares one electron with the other. After sharing, now both of them have got two electrons in their K shell or not? Tell me.
Oh, yes,
Sir,
sir.
Yeah, Abu Bakr.
sir, how much marks is the case study?
Case study is of the same marks as mentioned over there.
Sir, can you
One
speak?
second. So in Zambal words in two words into Zambal words in is two words. Actually, they are two different words, Priyanka. Okay, no? Like this,
Yes, sir. Like there
but
are
they're
two
related.
different.
They're related actually. Like not they're completely
Um,
different. Okay.
no, like not like that, sir. Like there like every letters, in that letters and this letters are mixed with this letter words.
One second, Doha. See, um, in this one, no, like COBMTSOUI. Okay, it's a
Yes, sir.
separate word will be formed out of this, and from the second one, ANTOCIUBOM, that will be also a separate word. Okay, no.
Yes, sir. But then
Hmm.
um, like you see the first word
Hmm?
and their words are like different, right?
Mm,
Like no, like
OMG.
placement.
No. It's not like no. The letters are different actually. S is not in the second one. See, if you look carefully, S is not there in the second one.
Sir, the marks for the case study is not written.
Actually, for the eight one, for that one, this 2 plus 2 4, 4 plus is 7, 7, and that will be carrying 1 second. Total of 16 marks is there now. Okay. 1 second, 1 second. Okay, consider that to be of 9 marks then. Okay.
Yes, sir, 4.5 marks.
Yeah, 4.5 marks each. Okay. Yeah. So back to this. Hope you understood it now, Priyanka.
No, sir.
Not getting it. See, these two are separate words actually. COBMTSOUI and the second one ANTOCIUBOM. Both of them
Yes,
was different words will be formed out of this. Same with the
like
second one also. Like for example, how do we say? Mm,
sir,
they are
like
interrelated actually. They are not completely different.
so that's not what I meant. That's not what I meant.
Okay, please explain again.
So can you solve the 11th first one, like the one we don't need, like the A?
Okay. Okay, this one you're saying, no?
Yeah, can you show
See,
me?
for the second one, it will be FUELS, fuels, right now. For the second one, it will be fuels. Everyone look at the second one here. My screen is visible now properly. So that will be fuels, FUELS. Okay. Now you look at the first one. Okay, look at all the letters. What can we make out of it? Mm,
Fossil
okay.
fuels.
Actually, one S is missing in that. That's why, like, I removed actually. Okay, na?
Okay, sir.
Mm-hmm. Let me look at the second one. Hmm. Okay, you guys solve it right now. Okay. I will discuss it if there are some errors in it. If there's some error in it, you can just skip and do the next question. All right.
Okay, sir.
Okay, okay. Let me get back to it now. So what I was saying moments ago, Duha, about this thing, hydrogen, right? So both of them have now fulfilled the duplet rule. Both of them have got two electrons in the outermost shell, that is in the key shell. How many
Yes,
electrons
sir.
were shared by them? One electron
Yeah.
shared by each, right now. So thereby their valency will be one here. It will not be plus one or negative one. Simply it will be one. Getting it now? That is the thing.
Yes.
So in this, we will simply say the vacancy is one, no sign with it. Hope you have understood it. Okay.
Yes, sir.
If you have understood, let's do some question on this valency. Okay. By the way, just like we have done the electronic configuration for hydrogen, we can do for the helium also, right? Okay.
Yes, sir.
Now guess what will be the valency of helium? Think about it. I'm giving you some options. Will it be 0? Will it be 1, 2, or 3?
So helium has two protons and
Hmm.
wait.
Mhm. Does it need to fulfill anything? It only already has two electrons now in its outermost orbit. So
Uh,
is it satisfying the duplet rule?
yes.
Right? So there's no need for it to gain, lose, or share electrons. Okay, na? That's why in the periodic table you will find there are different groups in and periods in the periodic table. And helium now, it belongs in the inert group, inert gases. It belongs to the noble gas group. Understanding what I'm trying to say? I hope you have looked
Yes,
at the
sir.
periodic table. Give me a second. And helium does not react with anything, right now? Getting
Yes,
it?
sir.
Since it is not sharing, losing, or gaining electron, so how can it react with anything? So chemically, they are actually inactive. You understood what I'm trying to say?
Yes, sir.
So reaction will only occur na, if an atom shares, loses, or gains electrons. So in the periodic table, look at it. Okay, look at the group number 18. You see helium on the top here.
Yeah,
Okay.
yeah, yes,
So 0 will be its valency. Okay, before we continue, let's do some questions on it. All right. So we have to find the valency. First, let's find the valency of nitrogen. One more thing I will tell you about it. See, if in the valence shell now, the number of electrons are 1, 2, or 3. So then the atom will actually lose it. Okay. If it loses one electron, so plus one will be the valency. Two electrons have been lost, plus two, three plus three. Understood now?
yes, sir.
So
So
valency,
valence shell means the outermost shell, right?
exactly, exactly. So valency will be positive. Okay. Suppose if in the valence shell there's four, so thereby the atom will share it. Okay, now will share it. Okay. And in that case, the valency will be 4. For example, the valency of carbon is 4. Okay. Now suppose if the in the valence shell the number of atoms happens to be 5, 6, 7. In 8 already you know that if it is 8 then it will be fulfilled now. No need to share,
Yes,
or lose, or gain anything. So if it is having 5, 6, or 7, then it will always gain. Why so? Because suppose if an atom has 5 electrons in the outermost shell. So it is much easier for the atom to gain 3 electrons to fulfill the octet rule than to lose 5 electrons. Hope you have understood this.
Yes, sir.
Now, talking about when the valency of an atom can be 4, let me quickly discuss this. Then I'm going to give you some questions. Okay. Suppose we have carbon. Look at the periodic table and tell me what's the atomic number of carbon. Here's the carbon. Okay. At the head of the at over here is the atomic number, that is 6. All right. Okay, and
Yes,
double the number, and that is 12, and 12 is the atomic mass, by the way. Okay, na? You
yes,
can
sir.
observe one thing, Doha, here. The atomic mass of an atom is now roughly double the atomic number. For nitrogen, it is roughly 14. That is double of 7, right? For 8, it is 15.999, and for that is roughly double of 8. Hope you're getting that thing also. Okay.
Yes, sir.
Now let's get back to the topic here. Tell me the number of electrons that carbon will have.
Uh, sir, 4.
No. What was the atomic number of carbon?
Oh, 6.
6. So electron will be same as its atomic number. Okay, no? Please
Yes,
don't get confused in this thing. It is very important. Okay. Hmm. So that is the nucleus. Okay. That is the K shell, K and L shell. Okay. Total number of electrons is 6. By the 2n square rule, first shell will have 2, and how many electrons will go in the L shell?
sir, 4.
4. 2 plus 4, 6. Okay. 2 goes here and 4 goes here. 1, 2, 3, 4. Okay. But here's a problem. It has not fulfilled the octet rule. It is not in the stable state now. It can be stable either if it has 8 in the valence shell, or either it has 2. It can't have 2, because only these elements, hydrogen, helium, lithium, beryllium, can have 2 in the outermost shell and will be balanced, will be happy, will be stable right now. But this one
Yes, sir.
needs to have 8. Okay, what will it do? Will it lose, will it gain, or will it share?
Sir, again.
No. How many electrons are there in the valence shell? 4, no?
Yes, sir.
What will it do? It will share now.
So,
Getting it?
yes, sir.
Okay, no? So carbon, like it can gain 4 electrons, but it will make it highly unstable. It can lose electrons. Okay, na? It can lose electrons, but losing it is very hard. So the best option for it is to share the electrons with other atoms. Getting it now? So it is going to
Yes,
share.
sir.
Okay. So
So,
valency.
sir, if,
Mhm.
for example, the element for example, if on the periodic table there's an element and the valence shell is if the valence shell is 4, so it can share, right?
You should not be saying valence shell is 4. You should be saying the number of electrons in the valence shell. Valence
Oh,
shell is
yes,
the
sir.
outermost shell. Outermost shell. L here is the outermost shell now,
Yes,
right?
sir.
So it has got 4. So if in the outermost shell there's a total of 4 electrons, so it will always share it with other atoms.
Okay, sir.
Good. How many electrons were shared? 4 now. So valency will be simple 4. Neither plus 4, neither minus 4. Okay.
Yes, sir.
Hope you are getting all these things and not getting confused.
And yes, sir, I understand.
Understand now? Good. So if you have understood, let's find out valency of some of the elements. Okay, so first, let's find the valency of nitrogen. Second, let's find the valency of sodium. Okay. Okay, what is the first thing you have to Find the atomic number of nitrogen. What is the atomic number of nitrogen? Look here. Where is nitrogen? Duha, read the name of elements. Read the name of elements. First 20 elements. Read it quickly.
Okay, so so there's hydrogen, lithium.
No.
Oh wait,
You
sorry,
start
sir.
from here.
There's hydrogen, then helium,
Hmm.
then lithium, beryllium,
Boron,
boron, carbon, nitrogen, oxygen, fluorine, and neon,
sodium,
sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon,
potassium.
potassium, and calcium.
Very good. Okay, here's the nitrogen now. Okay, Abu Bakr, I have got it. Thanks for sharing. Okay, and here's the nitrogen. What is the atomic number of nitrogen?
7.
7. Good. So what will be the number of electrons in nitrogen? See, the number of electrons will be same as
7.
its atomic number. Okay,
Yes, sir.
electron will be 7. Okay, so from here onwards you solve it.
So all the elements
Mhm.
in the periodic table are they're not ions, right?
They are not ions.
Yeah, because
Ions, ions are
so
basically
like
charged particles. Continue.
oh yes, so because my teacher told me that the
Mhm.
atomic number can only be equal to the number of protons because sometimes the atom can lose
Yeah,
atoms
I got it what you're saying.
electron.
That's why I was saying you earlier also. Okay, over here I have mentioned somewhere. I must have mentioned it. Like here, see, hydrogen. I have written proton has this total of 1 proton and 1 electron in it, so it is a neutral state. So ions are formed when there's a loss or gain of electrons. Basically, they are atoms or a group of atoms that has gained or lost one or more than electrons. Thus, they carry a charge in them. Getting it now? Like
Yes,
right now,
sir.
we will learn how this nitrogen will become an ion. I mean to say how this sodium will become an ion when we will do its electronic configuration. And there are two type of ions. Like for example, take the example of calcium. Okay, calcium. Calcium's atomic number is 20 now, right?
Yes, sir.
K shell
Um,
2, L 8, M 8. Okay, and will it have N shell? No.
no,
Like because in the like it will have, but there will be 2 electrons in it only. But will it be in a stable state?
no, sir.
Because the outermost shell should have 2, but it doesn't have. So what it will do? It will lose it. Right now. So how many electrons were lost? 2 now.
2.
So +2 is the valency. So the valency of calcium is 2. Now what this calcium has become? Now it has become an ion having a charge of +2 on it. Getting it? So ions are
Yes,
formed if an atom loses the electron or if an atom gains an electron. If an atom loses the electron to become a positive ion, so we call that as cation. Understood? Cation. Or if an atom has gained the electron, take the example of chlorine, Cl for chlorine. Its atomic number is 17. The electronic configuration is 287. Okay. How much electron does it need in order to become a stable?
1 electron.
So chlorine gains 1 electron. Electrons are negatively charged particles. So if it gains one negative charge, 1 electron, so thereby its valency will be -1 or not.
Yes, sir.
Okay. Isn't it a negative ion?
Yes,
Negative
sir.
ion. So hence it is called as an anion. Understood it now?
Yes,
Hope
sir.
it is clear. Good. Now let's get back to this quickly about nitrogen. Please find out the valency of nitrogen yourself. Okay. Okay. Others are done or not? Bubakar, you're only done. Mustafa, tell me, are you done? And where's Priyanka?
Yes, sir, I'm done.
Okay. Share it quickly.
So I'm just stuck at jumbled word. I don't understand.
Oh, okay. Leave that one actually. Leave that one, please. Okay, no. I saw it actually like there's some mistyping in it. Okay, there was some mistyping in it just now. Moments ago, I observed that. Duha, are you solving it?
Yes, sir.
K L. Tell me what should I write here?
So the key shell will have 2 electrons,
And L.
and the shell will have 5 electrons.
Okay. How many electrons does it need?
3 electrons.
The electrons to
So
be gained is 3.
its valency is
Mm-hmm.
-3.
-3, exactly. I was not able to write the case equation to the forefront. Uh, okay, Abubakar. No worries. So valence will be -3. Hope you're getting it.
Yes.
Okay. Now similarly, find the valency for sodium also quickly.
Sir, I don't know the atomic number of sodium.
Okay. Look over here. That is 11. No. Where is sodium? Here it is. Right. Atomic number is 11. Okay.
Okay, sir.
So atomic number is 11. Solve it. By the way, are all is all your doubt clear from this chapter or not? Please tell me.
Yes, sir.
Okay, if there happens to be something that you'd like to discuss, please let me know. Okay, we
Okay,
still
sure.
have got few minutes here.
So the valency is 1
One exactly. -1 or what? +1.
plus 1.
Good. There's one more thing I would like to tell you. See that some of the there are different types of element now in the periodic table. Some of the elements are categorized as metals, some are non-metals, and some are metalloids. Getting it?
Yes, sir.
Okay.
So what are
Also,
metalloids?
metalloids are like having the property between metals and non-metals. In the periodic table, we categorize the elements into namely 3 categories. Okay, now we have, look over here, we have metalloids, non-metals, and the other ones are basically metals. Metals, non-metals, and metalloids. So here, all the metalloids are shown here in these colors. See, boron, silicon, arsenic, germanium, antimony, tellurium, and polonium. Okay, now these are the metalloids. Understood it. Then the one that you
Yes,
see
sir.
here, no, these ones like hydrogen, carbon, nitrogen, oxygen, phosphorus, sulfur, selenium is there. So these are called as non-metals. And you know about the property of the non-metals, right? No. So like they are poor conductors of heat and electricity, right? Now they are basically insulators. They are brittle. If they exist in solid state, they are brittle, but many of them exist in the gaseous state. And this zigzag line, as you see, that was the metalloids. Okay, now. So they show
Yes, sir.
property of both metals and non-metals. Okay, they have both the properties. And metals, as you know, like these ones that you're seeing here now, all these ones, these are the metals over here. Okay. There was one more thing I would like to discuss with you. See, uh, in a molecule, there can be different number of atoms. Okay, now there are different number of atoms. For example, consider the case of hydrogen. So hydrogen forms bond with another hydrogen, and this makes up a molecule, right?
Yes, sir.
Okay. So in this one, how many atoms are there?
2 atoms.
2 atoms. So it is called as diatomic molecule. What kind of molecule is it?
Diatomic molecule.
Diatomic molecule. Okay. Then suppose we have got another one. Let us say that we have, um, let's say helium, right? So helium is a noble gas now. It is an inert gas. It does not form it does not form bond with any other atoms. So hence it has
Yeah.
like it stays alone. So it is called as monoatomic. It is monatomic in nature. Getting it? Or let us
Yes.
consider the example of like sulfur. So sulfur is polyatomic in nature. It forms bond with multiple atoms. Understanding it.
Yes.
So suppose we have got sulfur. So it will form bond with multiple atoms. So thereby we call this as polyatomic. Okay. Respectively, it will be forming bond particularly with a total of 8 different. Okay. And usually it exists as 8 in nature. Okay. Na? And call this octasulfur. What do we call this? Octasulfur. Octa for 8. Okay. So it forms a ring shaped molecule actually, where all the
Oh,
eight sulfur atoms are bonded together. Understood?
okay, sir.
Huh. So the number of atoms found in the given molecule is being referred to their atomicity. What do we call that?
Atomicity.
Atomicity. It tells us like how many atoms are found in a given molecule. Got it? What were you saying about, because I also have the chapter metals and non-metals for PT2. Oh, why did you mention it earlier? Okay, thanks for letting me know. When is your PT2 exam, by the way?
Sir, they did not tell us yet.
Okay, okay. Just one more thing I would like to discuss with you, Doha. Others can leave the class. Okay. All right. Now suppose that an atom has got some mass number. Okay. Suppose there's an atom XYZ or something, and the mass number of atom is, let's say, 40. All right. And the atomic number is 18. And the question has been asked us to find the number of protons, number of neutrons, and number of electrons in it. Getting it, Doha?
Yes, sir.
As we know that atomic number is basically we find out the atomic number by
The
finding
number
out
of
the number of
protons.
protons. So atomic number is 18, so thereby proton is 18 here,
Yes,
right?
sir.
Then we know that mass number is basically the
The
sum
sum
of
of
proton
the.
plus neutron. Good. In the question, mass number is provided 40. Proton you just have found out to be 18. So thereby won't you be able to find out neutron? That will be 20,
40 minus 18. Yeah, that'll be
22. So
22.
neutron is 22. Okay. Now, if this atom is in a neutral state, so won't the number of protons and electrons be same?
Yes, sir.
So will the electrons not be again 18?
Yes, sir.
Right now? So hope you have understood this. Any questions from this?
Sir, the mass number is the total number of the.
Proton plus neutron. You add
Oh,
proton
okay,
and you
sir.
add neutron. Like 18 plus 22 will again give you back 40 here, no?
Yes, sir.
Okay. So I will take out some